Hello, this is Pablo Galve, and I'm going to provide you with the solutions to the exercises that I gave you earlier. This content is generated for the Polytechnic University of Catalonia. So, first of all, you have to go to the GitHub release section so you can download the files that you need. Then we go to the folder, go to exercises and open the solution because we are going to work there. Okay, first of all, you will see that when you press the execute button, it will throw you an error because you don't have the DLLs included. So you need to go to depuration, properties, and you will see depuration, and in working directory you have to go to examinate and find the game folder. You need to do that because if not, the DLLs will not be included and it won't work. So we are in the to-do one. If you want to search the to-do, you have to click Ctrl-Shift-F. It will open a window like that and you write to-do and press enter. So you will have the to-dos here. Now, to-do one. We are using an external library called fast noise. So in order to use it, we need to create an object. So we create fast noise, my noise. Then we need to change the default noise to Berlin because by default it uses simplex. So we call our object my noise, set noise type, fast noise, Berlin. Okay, the next step is to uncomment that line and change my object with my noise so we can use the seed. And the last thing for the to-do one is to change the frequency that we'll be using. So my noise set frequency, and we have a variable called frequency. What is that variable? Okay, if we go to the folder game, we have a file called config. We can edit it here, or we can also bring it to Visual Studio. And if you see frequency value, default seed. So we have data here that we can change. We can change the inputs that we give to the algorithm so we can get different results. And that way, we don't need to open the entire project. Only with that file, we can change the results. And if we go to Procedural Map Generation, generator, in the awake function, we see that we are loading the data from the file. So now we go to the second to do. We see that we have an iteration here from 0 to 1 in both coordinates in x and y, and we need to store the Berlin noise in a variable called heightmap. But I write heightmap and nothing appears. That's because the variable is stored in map. So we go up, map, heightmap. We write x and y, and we call my noise get noise because the noise is generated. We only need to call it, and we introduce the coordinates for the noise. And we press the play button to see what happens. On screen, we see something weird. It is not normal. So if we go to the console, we see that it sometimes is generating negative numbers, but we should always get numbers from 0 to 1, so it's obviously an error. So in order to fix that, we need to add a formula. So to that we add +1 and divide by 2. But a division takes computational power, so it's better to multiply by 0.5. It's the same, but it takes less resources. So now we press the button and it shows us the heat map. Okay. Now all the numbers are from 0 to 1. So now we go to the to do 3. Now we see that we have some values loaded from the config XML. We can see them here: the water, sand, grass, forest, mountain, and snowy mountain. But we need to go here. We see that the heat map noise is stored in the value variable. It is used for convenience because it's a shorter name, but we could also use directly that variable. And here we are using that in order to see the noise, but we need to comment that because we are not going to use it. We are going to bleed textures. So with that, you will see some water appearing on screen. You see? You see that water is on screen, but the rest is black because it is not defined. I mean, we have an if statement that says if the value of the height map from 0 to 1 is greater than water value. What is water value? You might be thinking. Water value is 0. So if the value in the height map from 0 to 1 is between 0 and 0.3, we are going to bleed the water texture. And if we hide that statement, the entire map will be water, as you will see in a moment. Now everything is water. So now we have to do some if and else if statements. I'm going to copy them from the solutions. So we can use that. And now the map will be generated with all the different textures. As you can see, now we have water, grass, mountains. But we see that if we press space, it generates a new map, but it's using the same seed, so it's always the same map. It's not random at the moment. Okay, so I think that the 2-3 is over. Another thing you can do is change the scale. Now it's at 0.3. If we put one in scale, it will be zoomed in. As you can see, now we look at it from more near, and if we put 0.1, we see it from more distance, as you can see. So you can use the value that you want. it's only visual. So now we go to the for to do. We generate a random seed. So normally the seeds are taken using the current time in milliseconds. So we call time null and multiply by 1000 in order to make it milliseconds. You have to you have to include the library that makes possible to call the time. And now we have to go to the last to do, and you have to use the seed both when we start the program. You need to go to app procedural map dot generate seed. We copy that and we make the same here. So now we have random maps. When we press space, it will generate a completely new map. As you can see, it's always different, which you can move with the arrow keys. If we change the values in the XML, for example, we put the sand from 0.5, grass from 55, and that, almost the entire map will be water, or a big portion of it. As you can see now, the water is taking a lot of space. Or for example, if we take sand as that, now a big portion of the map will be grass, as you can see. So you can change the inputs in the config file and you will get procedural maps, but they are not completely random but pseudo-random. So you can edit them as you want. And oh, of course, if we press the F1 button, it is going to generate the default map with the seed 1337. And now we go to the optional homework that I gave you. It explains how to generate an infinite map. So in order to achieve that, you need to apply occlusion culling to only render what it's seen on screen, because at this moment we are rendering everything, even if you are not seeing it, and that takes computational power. So for an infinite map, you need to optimize those resources. Another thing you would need to do is to generate the Perlin noise for all the coordinates seen on screen. At this moment, we are generating coordinates from 0 in both axes x and y to 100 in both axes. So in order to achieve infinite maps, you should generate coordinates generate noise for all the coordinates on screen. So with that, you should be able to create an infinite map. That's all for the moment, and thank you for your time.